So, what's the first one? X squared to the power 4, Omar. Sorry, Amar.
No, call me through that. You call me through that. X to the 8th power.
X to the 8, perfect. So in multiplication, we multiply the powers. So we have two powers together. We multiply them. We get, let me change the power, X to the 8. The next one, 2x whole thing to the power 4. I talking about B or C, which one?
4.
So Jack, which one, B or C?
What was
Okay, tell me what's the answer for C.
X cubed over 8.
X cubed over 2 cubed, but 2 cubed is 8. So in division, we distribute the power. Okay, E. One over 3 cubed, which is 1 over 27. The denominator is bigger, our answer has to be on the denominator. If numerator is bigger, the answer goes on the numerator. X to the negative 1.
No, hold on. X to the negative 1 over
1 over X. And then cube root of X squared. X to the second power over 3. Perfect. Now the next column. 2x whole thing to the 4. Amar.
That would be 16 X.
So you distribute, you get 2 to the 4, X to the 4, which turns into 16 X to the 4. Another multiplication. 2 cubed times 2 to the 7. 2 to the 10. You add the powers when you have the same base. And 2 to the 10 is a big number, so do not even try figuring out how much is that. F, 3 to the 7 divided by 3 to the 4. Good. 27. So subtracting 4 from 7, you get cube. It turns into 27. Now 2 to the negative 3. Amar. 1 over 2 to the positive 3, which turns into 1 over 8. 2/3 whole thing to the negative 2 power. Eliza. J, huh? 9 over 4. So first you flip it inside, you get 3/2 square, and it becomes 9 over 4. So to turn negative power into positive power, it just had to flip the fraction. And now comes all the interesting rule about 0, 1, negative 1. What is anything not 0 to the power 0? 1. That tells us what is 0 to the 0. 0 to the 0? Doesn't exist. That's why.
No.
If you give both of them, it's wrong.
For real?
Of course.
Robert took me with 0. No, he did not.
I told you, like.
Put 0 in NP, but are you allowed?
Yes, we had an argument about that. Not argument, we had a conversation a long time ago about that. It doesn't return.
There's no such thing as a bad student, a bad teacher. Wait, so I'm gonna switch my tutor. He bought his degree. You need to switch your brain. Oh, wait, this one
No, I actually asked the department about that. Like, is 0 to the 0 really 0 or 1? And they told me, no, it's DNA.
Okay, but
And
hold on, logically speaking, to some scientists.
mhm.
Zero to the zero power, how does it not exist? Isn't it just zero?
No.
Put zero in, let me build
Okay, let's see what calculator tell us, okay? We have 0, and this is the power symbol, x to the y. 0 to the power 0. So what do you expect to see? 0, 1, or DNA? 0. They are telling 0 to the 0 is 1. See?
So are you lying or are they lying?
0 to the 0 doesn't exist.
Depends on it.
Was that your?
Depends on how you land it.
I learned it.
But I asked the department, they said no, it doesn't exist. So
Robert, that's like the
0 to the 0. See?
Why would you put zero, both zeros on the end? Double trouble.
0 to the 0 doesn't exist.
I got that right. But zero or DNA.
Okay, so I'll ask the department again. Are you sure 0 to the 0 doesn't exist? Why the calculator is showing 0 to the 0 is 1? Like, it doesn't make sense. Yeah, I'll double check. See, that is one controversial math problem. What is 0 to the 0? Depending on which level math you are on, we have different answer. Okay, one that is most generous. The next one. What is 1 to the any power? 1. So without any doubt, we know this is true. 3, okay. What is negative 1 to the odd power? It could be odd fraction, add a whole number, add anything. Negative 1. That means what is negative 1 to the even whole number? Positive 1. So why do we have to write two parts for even, one for the fraction, one for the whole number? What's the difference?
You still get credit. You can't. Remember, you still get credit if you put odd or even, you'll have to put 1.
No, I'm right. I didn't miss anything. I'm asking why negative 1 has double even power. One is whole number, one is fraction. What's the difference between them? Good. What did you say?
I said, I can answer it. It's, because you can't have a fraction as a negative. Oh, you can't negative, you can't fraction.
Fraction with a negative negative 1 with a fraction power doesn't exist. Why not? Because let's think about that. Negative 1 to the 1/2 power. It means square root of negative 1.
I'll put negative 1.
Can you find a number, multiply same number twice, turn into negative 1? Exactly. So that's why even though it's whole, even though it's even, but it has 2 parts. One is whole number, one is fraction. Whole number gives us a result. Fraction is imaginary. It's not real. See? But for add, it doesn't matter. You can have add fraction, add whole number, add decimal, add anything. The answer is always negative 1. Okay, what is 0 to the any negative power?
Put the end.
It is DNA. Why you're not confident? Think about any power. 0 to the negative 1. What does that mean? 1 over 0. Can you split 1 into 0 pieces? Impossible. So DNA. And the last one. What is 0 to the any positive number which is not 0?
1.
Huh? 0 to the any positive number. Let's say 0 with a square. What is 0 square? 0 times 0 is 1?
0.
0.
100. Yeah. Oh.
0 to the any positive number means you're multiplying them. Or even whole fraction power. 0 to the 1/2 means square root of 0. What is square root of 0? 0. Cube root, which is 1/3 power. Cube root of 0. What is cube root of 0? 0. So you can have odd number, you can have whole number, you can have even number. It doesn't matter what you have. as long as those numbers are positive on the power, the answer is always 0. Okay. So if you get confused about the rule, just have an example like me. And then you see the answer in front of you. Except 0 to the 0.
Question 6 then.
Yeah. I had to rediscuss what is 0 to the 0.
But what does that mean for our grade?
I told you DNA, so you're supposed to give me DNA. Mm-hmm. Okay, any question before we start? In our next class, we are going to have another quiz. No, actually, next class will be too much because I have an exam to grade. Next week, Tuesday.
Wait, next week is going to be about what?
About graphing exponential equation. And then today we're going to learn graphing logarithmic equation. So graphing logarithmic equation, graphing exponential equation. Jack, question?
Hold on.
About
What was that? Put me on transformation.
transformation. Okay, so in our last class, we talked about money problems. To solve any types of banking issue, money problem, you have to memorize these two formula. The first formula is when you're compounding your money several times in a year. So you can see your N, like if you compound weekly, monthly, annually, daily, you have a number for those scenario. So you use the first formula where N is those numbers. And the second scenario, when you compound continuously. When you do something continuously, there is no way you can put a number for continuous things. So you have to use the second formula part. A equals P times e to the RT. And in the final exam, there'll be at least one of these. There could be two, but at least one. Okay, so we did all these examples. If you forgot, please rewatch the recording. In memory will be refreshed. We don't have time to refresh everything. Already are 45 minutes late. No, 50 minutes late to start our lecture. Okay, one question before we go to the next section. How long it will take for an investment of $5,000 to double the amount with an interest rate of 3.5% if you decide to compound annually. So you're investing $5,000 and you want to make it double. What is double of $5,000? $10,000. So you want the final result to be $10,000 and you're investing $5,000 to them. So you went to the bank and tell bank about your scenarios. The bank said, okay, no problem. I'm going to give you 3.5% interest rate. And now you're asking the bank, well, with that low interest rate, how long do I have to wait for my $5,000 to turn into $10,000? So you think it's 11 years? Okay, let's see. Any other guesses? How long it will take for $5,000 to turn into $10,000 with 3.5% interest rate? How long? So definitely more than 10 years, right? Okay, let's see exactly how long. So which formula? Part or the first one? Part doesn't have any n, but here you're compounding annually. What does annually means? Once. If you do something annually, it means you do only once a year. So if you can put a number for your compound, then it's not part. Part is when you cannot put a number, like continuous. So we have A equals P, 1 plus R over N, whole thing raised to the power NT. Please memorize this formula correctly. You need this formula. So what is the final amount we are hoping to get? 10,000. How much you're investing today? 5,000. 1 plus. What is the interest rate? Good job, 0.035. So 3.5%, you have to move your decimal 2 places to the left. So you get a 0 in front of 3. So 0.035. And how many times you're doing it in a year? 1. Whole thing raised to the power n, which is 1. And do you know how long it will take? No, this is what you're looking for. How long it will take. So we are going to clean this little bit up. So divide both sides by 5,000. What do you get in the left side? 2. And if you look at the inside, how much is the inside? 1.035. So this becomes 0.035. 1 plus 0.035 is 1.035. Raised to the power t, 1 times t. Your t is on the power. So you're solving for t. Square root of t is not, it's not going to make you t coming down on the coefficient. You cannot divide because this is the base. What did you learn? When you have a power, it brings the power down. Log. For every exponential equation, if the bases are totally different, you cannot do anything with them, you go to the log family and get the log.
Love or love?
Not log, log. Either you can use log or you can use ln. So log, you go to the log. What log does, it takes the power down as a coefficient. It brings it down. So from here, you get log of 2 equals t times log of 1.035. So there is no more power. The power becomes coefficient. And that is what we wanted to solve for t. Now to solve for t, what is our last step? By log of what? We have double log. Which log? The log on the right. Whatever we have next to the t. You want to get the t alone. So you need to get rid of that. Log of 1.035. So you go to the calculator. We have 2 log. You divide that by 1.035 log. Click enter. 20.14. 20.15. Wow. So not 11 years. You have to wait 20 years. What are you doing, guys? Turn it off. 20, you have to wait at least 20 years to make it $5,000 into $10,000. And that's because the interest rate is too low. Any question? So again, in the final exam, we'll have at least one of these. And in the in-class exam, you're going to have 2 of these. One for the part formula and one for this formula. Unless they tell you in the question. Then it's up to you. So it's more than 20 years. With this, you're done with 12.3. Now 12.4, we are going to do exponential growth and exponential decay. So in exponential equation, we have 2 special types of exponential equation. One is the growth rate and one is the decay rate. So we use growth rate especially to observe bacteria family. if you're working with bacteria, any type of bacteria or any type of those things, biological things, then you need to see what is their growth rate. And for decay, they mostly use decay for minerals. How long it will take for a mineral to decay into from that amount to this amount. But we use many other places like wildlife population, financial investment, biological samples, natural resources. Also, these are for exponential growth. For exponential decay, we use for radioactive isotopes. You may not have any idea, but if you take chemistry, you'll have idea what they're talking about. So the growth function means it's increasing. So when you move from left to the right, you're going up. And decay means you're going down. When you move from left side to the right side, you're going downward. So in a decay function, we have our base. Our base is a fraction. That's why you're going down. And in the growth function, our base of the exponent is more than 1. More than 1, that's why you're increasing or going up. But they both have the format of the part, which is same as the exponential format, a times b to the x. And instead of x, they use the time and constant. So the format for exponential growth or exponential decay is based on the continuous compounding function, where you have an initial amount and then a base to the power, some constant rate, and times time. So the base, it could be E, it could be any other number. It doesn't have to be E always. And K here means some type of constant rate. Like for our part formula, the R means interest rate. Since here we are not working with interest, so K means a constant rate of changing. And T is how long it will take. One of the most well-known decay function is the half-life. And one of the well-known growth function is the double life. Like the double money we just did, we also look for double life. Double life and half-life. For half-life, our base is half. For double life, our base is 2 instead of E. Like the doubling money. How long it will take to double your money? It's a double life. Okay, one example. And also in the final exam, they'll ask sometimes this type of question from half-life, double life. So here it says the population P in T years from 2000 can be approximated using this model. P equals 2000 e to the 0.05 times T. Find the population in 2015. So in 2000, we have this formula, 2000 times that. And if you want to find the population in 2015, what is given here? But what you're solving here, solving for? There are two variables. One is P and one is T. Which one you're solving? What is this 2015? That's the T. They give us an information. So do you substitute T with 2015? We look at the difference. For 2000, it's T. So for 2015, our T will be 2015 minus 2000, which is 15 years. So they actually gave us the year, how many years we are waiting. So 2000 e to the 0.05 times 15. That means we don't need the log because there is no variable to solve for on the coefficient on the power. We only use ln when we have a variable on the power that needs to come down. So go to the calculator and find out how much is this. Use a calculator. You have to do this in your exam. Krish, no computer, please. And Cairo, I don't see your screen. So you should close it and get a paper and pen.
Yes, I got it.
How much?
So you wanna estimate or
Yeah,
can't get point units, right? So it's gonna be 31, 538.
31, 5, 38. 31, 5, 38. So 31,000. Let me see, what do I have? I have 33. Why do you have so low? 2,000 times. This is our E to the power. So click on the power button and then 0.015. No, 0.05. 0.05 times 15, close the parentheses. Okay, this times 2,000. No. Wait. So let me get the exponent first because I don't get. So first, let's do the exponent here. This thing. So e to the power, this is our power thingy. Inside the power, we have 0.05 times 15. Hold the parentheses. Times 2,000. 4234. What did you do? 42? That means this answer is wrong. 33636. Or did I do something wrong? From 2000 to 2015, it's 15 years. And you have 0.05 and you have 2,000.
No, you're right. Let me just double check.
4234. 4234. 4234. Then what's wrong with this? Or probably this is the answer for another question. Oh, you have to put the multiplication symbol. On the E, you have to put a parenthesis. Okay, the next question. The size of the bacterial population is given by this information. After how many hours, did you figure out? After how many hours the population will be? 130,000. So what did you do?
It was 2,000
Mm-hmm.
times, where's it?
Times e to the
E times e to the power of what? 0.
Now you have to put parentheses because your power, you're going to put two things.
0.05
Times 15. See? That's why you guys have to play with your calculator. If you don't know how to input everything correctly, not the phone calculator, the actual calculator you're going to use in the exam. And in the next exam, you need to have a calculator. And in next exam will be when you come back from your Thanksgiving break. Let me take your attendance now. How long? Yep, because it is on the power. Anything you're solving, anything from the exponent, you need log.
And we won't be just like on this section or everything.
Of course not. Everything after exam 2.
No, I'm saying like,
Of-
I'm gonna be like,
Everything after exam 2. Whatever we started learning after exam 2,
oh, so it's not gonna be everything.
not cumulative, but everything after exam 2. Your final exam will be cumulative.
The fun.
Mm-hmm. So you need to refresh all the memory you already forgot, like the exponentials.
You didn't review it.
That's my plan, to review at least for 2 to 3 days. I can do 2 reviews with you, 2 reviews with my afternoon class, so you can have 4 review videos. And you can watch them during the weekend. Your exam will be Tuesday. Our last day of class will be Thursday, and your exam will be Tuesday.
You gotta be here early, right? 8.
Your exam will start from 8. You have to be earlier than 8. At least 15 minutes before 8.
You gotta wake up at 5 that day.
Yeah, I hate that.
See it on YouTube.
I wonder, like, people who live on Staten Island or far from here,
That's why you didn't.
why does he live Staten Island? Yeah. Krish, no laptop, no laptop. Is it closed fully? Is it fully closed? Jack, Eliza here, Karen here, Alana here, Maria here, Daisy here. Try this question, guys. Isn't it free time? I'm letting you do this question. And then we have another one. Try the next one. All of these questions will be in the exam. You don't know which one, but one of these. And all of these are previous final exam questions. Justin, Parchung, Alera, here. Hiba, here. Shahida, here. Loisville, Marlene, she was here, right? Yeah, she took the exam. Cairo, here. Jiajun, here. Valerie, here. Erie, here. Amar, here. Amen, and sense.
Well, this log, and then the E cancel out.
For E, you cannot use log. You have to use ln.
Then they will both cancel out.
Cancel out.
And then what would I be left with?
The power.
That's a whole number?
Not a whole number. It's 1.31 times t. So they cancel out when you apply ln.
Mhm.
That means there is no more base. This thing comes down. The power becomes coefficient.
It looks like brown. And then I'll be left with ln 25
20.
equals t. Do I have to like,
Not t, that the whole thing.
oh, okay.
And then to solve for t, you need to divide both sides by the coefficient. Amen. Absent. Nihan here. Ingrid. Here. Sophia here. Antonella here. Ronald here. Good here. Ebony here. Zohaib not here. Terence probably late. Why is it t? On the coefficient or on the power? So if you have anything on the power, you need to solve for. What do you need? Here you cannot use log because you have a special base E. ln.
Hold on, I got a question. So you said 130,000 people there.
So we have P equals 50,000 e to the 1.31 t. And they're telling us about the final population. Our final population comes into 130,000. That equals 50,000 e to the 1.31t. E equals 2.49. Probably no. Our goal is to solve for this t. What do you do? By 50,000. How many zeros I'm putting? 50,000. So they cancel out. From here, you get 1 0, 2 0, 3 0, 4 0. All the zeros cancel out. So we get 2.6. 2.6 equals e to the 1.31t. Since this is a special base, so you have to use specifically the ln, not the log. Because the log and ln, they kill one another. So you're left to ln of 2.6 equals 1.31. Now to solve for the t, we need to divide both sides by 1.31. So our t equals ln of 2.6 divided by 1.31. What do you get? What happens? T equals ln of 2.6 divided by 1.31. Using calculator, what it becomes? 0.723. And this is the correct answer actually. 0.7. If you have 2, 3, how can you get 3 only?
What? I got 0.729. I got it.
0.729.
Ah,
So 0.73. Damn. What do I have? I have 7.3. Yep. Same. It's hours, 0.73 hours. So it's close to 1 hour. Okay, the next one with the coronavirus. Suppose coronavirus spread continuously, which is true. It spread continuously. It did not spread annually. It spread continuously at a rate of 26% per day. And it's from a actual data. When it started, first in New York, 2 people got infected. And then it was spreading with almost 26% per day. Can you guess how many people will be infected after 11 days? So what formula are you going to use? part. The hint is a continuous. Anytime something is continuously happened, means part. We're going to modify that a little bit, but it's the part. So the final amount is initial amount times e to the rate and t. So this rate, in realistic situation, we use k for that, which is same as interest rate, is 26%. But what is 26%? 0.26, no more zero. 26, you move the decimal 2 places to the left, you have no extra place. It's 0.26. So 200, so let's see. So fast, 2 people got infected. And it's spreading 26% every day. And we waited 11 days to figure out how many people infected or died. I mean, that time everyone infected was dead, right? They were dying. There was no cure for that. And I was so afraid that I was going to die. Like I was literally very, very scared at that time. So find out how many people died or how many people got infected after 11 days, just after 11 days. Hmm. 34.92. Since it's human beings, you have to round up. 35. Really? Only 35 people? I was expecting more. But 26%. See, when you give 26% interest rate as money, it's a huge amount. But 26% in this scenario is so low. Unbelievable. Okay, anyway, the answer is 35 or this. For human being, this is more realistic, 35. Okay, let's see, one more question. Half-life. The half-life of an isotope is 96 years. Means if today it's 1 gram, after 96 years, it will be 1/2 gram. This is what half-life means. Today, if today we have 1 gram of something, after 96 years, we will have 1/2 gram. The half-life of 96 years is a huge time. It's a long time. How much of 40-gram sample is left after 200 years? So today you have 240 gram. This is the initial amount. How much you have today? Which is P. What is 96? Initial T. And we have 2 T's, right? 200 is also T. 96 is also T. No, we did not subtract. First, you have to find your rate. Did they give you any rate? No. So what is missing is rate. They gave us double time because we need the first sentence to find out what's the rate of change or what's the rate of decay. How much, at what rate they're decaying, they're decreasing. So we start with the first sentence. Half-life is 96 years. It means the final amount turns into half if the initial amount is 1 today, right? Initial amount is 1 means the final amount has to be half. And e to the interest rate, how long do we have to wait to get the 1 gram turned into half gram? No. Half-life is how long?
96.
96 years. The part formula. A equal, okay, I should write it down. I thought you already know that. A equals P e to the RT. So our final amount will be half. That's why it's called half-life. Final amount is half. That means initial amount is 1. And we waited 96 years for the 1 gram turns into half gram. So we get 1/2 equals e to the 96R. Our goal is to see what is the interest rate. So ln. We cannot use log here. We have to use ln. And we can use log, but they don't cancel the e. Our goal is to cancel the e, so we need the ln, specific ln. We get ln of half equals 96R. So we divide by 96. We get R equals, how much is that? ln of half divided by 96. What is the interest rate? Terence,
Yeah.
do you remember after you got your last exam, you told me, Miss, I'm promising you, I will never be late. I'll never be absent in this class. Do you remember your promise?
Okay.
Or are you able to keep your promise?
No problem.
Exactly.
Negative 0.07.
Negative 0.07. Do any of you have anything different than that? That's why I'm asking others. Do you guys have the same thing? Well, interest rate cannot be negative, right? So something is. You still have negative? Or because it's half is a negative. This is 1, so half is here. So yeah, half is a negative. Oh, because it's decay. It's decaying means negative. Eliza, what do you have? Negative? 0.1. Negative 0.01. So I have to check.
I got negative
0.5 ln divided by 96. 0.007.
That's what I said, 0.007.
and that means that-
Because it is 0.01, it rounds up to 0.01.
No, you shouldn't round here. The more you round, the more rounding error you get. So you shouldn't round at the beginning, you should round at the end.
And now,
The answer, this is interest rate.
wow, 40.
Now we are going to use the same formula again. A equals P e to the RT, but this time we know our R. And this time we know our T. So we are looking for the final amount. How much will be left if today we have how many grams? 40 grams. So today we have 40 grams and we are decaying at a rate of 0.007 and we are waiting 200 years. So how much of this 40 grams will remain?
I'm looking.
Find it, use a calculator. Trust me, guys, you need to use a calculator in the exam. Even though final exam will have multiple choice, but if you don't write your final answer, but pick the multiple choice, it's 0. 9.867 grams. You sure it's 8? 9.86. So what was the interest rate we got before? 722. Try putting 722 and see what do you get. Huh? 61? 864. But the answer they gave is 9.3. So we have rounding error. So we have to check. 40 times e to the power, and you're multiplying few things, 0.00722 with a negative sign in the front times 200, closing the parentheses, 9.439. So yeah, they don't want us to round. The more you round, the more you get rounding error. So with 0.07, we got 9.8. But the actual answer is 9.3. That means we have some rounding error. So I put 2 more 2s. But still we have rounding error. So instead of rounding, if you plug the entire thing, let's see what happens. Man, it will be too much. 40 times e to the power. And instead of writing negative 0.007, eliminate the entire thing. So you need to put double parentheses. 0.5 ln divided by 96. This is one parenthesis times 200. You're closing another parenthesis. Oh, it's still 9.43. 9.44. So when you round, you should have more places at the beginning so that at the end you get more accurate results. Rounding error is a huge problem actually in math. Right, it didn't specify, but here in the middle, anytime you round, you have to round at least few places, like 4 or 5 places. In the exam, it's closer, then it's fine. But if it's a huge gap, then it's something is wrong. So it will be, for example, here I see actually huge gap. 9.8 and 9.4. 9.8 is closer to 10, but 9.4 is closer to 9. So this gap will cause problem. And it's not full. This one is full. But this one is not even full. So E is a huge number. They put a huge E. So bottom line, put more numbers here. The more number you put here, the better results you're going to get at the end. Okay, one last question. Oh no, that was the last question. So in the final exam, whatever questions I did, there will be at least 1 or 2 of them. There will be 2 actually. One will be in the calculator part, one will be in the non-calculator part. So all these questions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. From 12 questions, there will be 2 in the final exam. Okay. So even though you hate word problems, please try to remember them. And now you're going to go logarithmic function. Any question? So all of these are exponential. Means radical, not radical. Variable is on the power, on the exponent. That's why it's called exponential. Now, logarithmic function. The logarithmic functions are the inverse of exponential function. The format for logarithmic function is log with some type of base b on the leg of the g of x. Here there are a few conditions. This x has to be bigger than 0. It will not have any negative. If you have 0, it's undefined. If you have a negative inside the log, it's undefined. So log can only take positive number, just like 0 power. 0 can take only positive power. Same thing, log can take only positive things. So positive side. And the base you see, the base cannot be 1 or 0. So base cannot be 0 or 1. And the side of the log, it has to be positive, strictly positive. Now the log function is equivalent to exponential function if you change the format. Log is written as log base b of x equals y, means this log value will give us some small number, not small number, like gives some straight number. It spits out some straight number, but this one can be rewritten as an exponential format. How? You take the log, it is the base from the log, put the right side of the equal sign as the power, set it equals to whatever we have with the log. So b to the power y equals x. This is the exponential form of this logarithmic function. So from log to exponential, exponential to log, we can always move backward and forward. They are the two formats of same function. Logarithmic and exponential are interchangeable. So the way I remember is that first I write down this format, and then I write as a cycle here. B gets x, B gets whatever we have here as a power, and we set it equals whatever we have next to the n, next to the log. Now their names. Whatever we have on the leg of the g, we call it base, and whatever we have on the side of the log, we call them argument. And this thing, many people call it differently. Some people call it value. Some people call it exponent. So this one, it has names like value, LUE, or exponent. We call it exponent when you write it as a exponential form. So b gets x as a power, and we set it equals to a. B to the x equals a. That's how I remember. It's like a cycle. Let's do some practice. We are given 3 logarithmic form, turn them into exponential form. If you wonder why do we care? Well, we care because we don't know how to solve logarithmic equation. So when you are solving logarithmic equation, you have to turn them into exponential equation. You must. Thus, I need to know how to convert log into exponent. So, who would like to try this one? What to the power what will be what? Nihan. 5 to the power 1/2 is radical 5. So 5 to the power 1/2, this is here. And then you set it equals to whatever we have next to the log. So 5 to the 1/2 is square root of 5. And this is true. 5 to the 1/2 is square root of 5. Okay, Terence, the next one.
B, right?
Mm-hmm.
So it should be
3 to the power of 3 equals 1 over.
Is this true?
Wait, that was right.
But is this true? If you multiply negative 3 times, that is turned into 1 over 27. If the statement is false, that means you did something wrong. You start from the leg, the base. So 3 to the power 1, 3 to the power negative 3. 3 to the power negative 3. And then the result is the argument. And this is true. 3 to the negative 3, the exponent rule you missed a quiz today. The exponent rule, it's 1 over 3 to the positive 3, which is 1 over 27. So you can actually check when you have a number. Okay, the last one. Who would like to try the last one? Amar. Fourth root of 6. So 6 to the power 1/2 is equals the argument fourth root of 6. Good job. And this is what you have. Good, right? Any question on this? Daisy, no fun. Now let's go to backward. We are given exponential, turn them into logarithmic. So when you do logarithmic, you write log. So you need to replace your base, your argument, and this side. Amar. What is your base? The argument, this is argument. Okay, let's check. 6 to the power 1/2 should be equal to the argument, which is square root of 6. Yep. The next one, log with a base and then argument equals something. Who would like to try this one? Justin. Base 5, 1/5, -1. So see, 5 to the -1 should be equals to 1 over 5. Yep, perfect. So see, we can go backward, we can go forward. Which one is backward, which one is forward? It doesn't matter. You can go back and forth. Why do you here? Because to solve logarithmic equation, you have to convert them into exponential. Now, a little bit information about log and exponential. They're inverse of one another. What does that mean? It means they are the same graph, but they just reflects about y equals x line. Y equals x line. Here, the blue one is exponential graph. The red one is logarithmic graph. It's the same graph. They reflected about y equals x line. It means y equals x is the mirror. So if you put a mirror here, this graph will turn into that graph. So same graph, okay? So exponential goes to the point 0, 1. The log goes to the point 1, 0. They switch their x and y. So the domain for exponential is the range for logarithmic, and the range for exponential is the domain for the logarithmic. So x on the exponential is y on the log, Y in the exponential is the X in the log. They switch the position.
Is it the same equation though?
No, this is Y equals B to the X. And this is Y equals log base B of X. So if you can find value for one, you can find the value for the other by switching the position. Another difference is that exponential takes a small number but produces a big number. On the other hand, log takes a big number but produces a small number. So exponential makes things bigger. Logarithmic makes things smaller. Okay? They're opposite of one another. For the graph, the logarithmic graph, it goes through the x value 1 for every which doesn't have any, every log graph which doesn't have any transformations, they all will go through the x value 1. Now, depending on what is your base, you get different shape. If your base is bigger than 1, there is an increasing graph. It means you're moving up. But if your base is a fraction, it means it's a decreasing graph, means you're going down. So your base is, let's say half here. And let's say your base here, I don't even see. Your base is 10 here, and your base is 2 here. Okay. Now, the bigger the base gets, the closer it gets to the x-axis. Look this one. Our base is 2, so it's far from the x-axis. Here, our base is 10, it's closer to the x-axis. So the bigger the base is, the closer it gets to the x-axis. For the exponential, it was the other way around. The bigger the number was, the closer it was to the y-axis. And here, the bigger the base, it gets closer and closer to the x-axis. Here we have more details, 4 of them. The red one is log base 2. The next one is log base 3. The next one is log base 10. And the last one is log base 200. 200 of x. See, the bigger the base is getting, the closer and closer and closer it's getting toward the x-axis. But without any transformation, they will always go to the x value 1. Always. Amar, no fun, please. Now, exponential, it has horizontal asymptotes. So logarithmic, it's going to have a vertical asymptote. No, the other way around. Yeah, it is true. For exponential, it is horizontal. Oh, yeah, the vertical asymptotes. So for logarithm, we have vertical asymptote, and where from we get those vertical asymptote is your horizontal shifting. Either you go left or right, that will tell us what is your horizontal, what is the vertical shifting. So for exponential graph, you had horizontal shifting, and we got it from up-down shifting. Guys, shh, shh. For logarithmic graph, it's a vertical shifting, but you get it from your left-right shifting. Left, right, shift. Okay, so they're completely opposite. So we can remember one, that means you can remember the other by just thinking about the opposite thinking. Also, it's opposite for domain and range. Exponential function has domain negative to positive infinity. So logarithmic function has range negative to positive infinity. Means the y value could be anything. But the domain means the x value cannot do anything. Without a transformation, it starts from 0 and then it goes to all the way to the positive side. But you cannot use 0, so 0 is a parenthesis. Log 0 doesn't exist. Okay, now this one says find graph it. Graph the following logarithmic function. So just like using other transformation, the log transformation is same. If you have a number inside your parentheses next to the x, what type of transformation you have? Up, down, or left, right? Left, right, which direction? Left. It's opposite direction. You have to go left 2 units. So you take the original log graph, which goes to the x value 1. So this is log 2 of x without transformation. You take this point and you go 1 left here, then 2 left here. So you move your x-intercept 2 places on the left and you draw your graph again. So this is log base 2 of x plus 2. Now you also have to indicate its asymptote. What is your asymptote here? Particle asymptote is x equals -2. You get the asymptote from here. When you solve for x from the inside, that's your asymptote. So x plus 2 equals 0. I should write this down. X plus 2 equals 0. That gives us x equals -2. So this is -1. So -2 is here. This is the line that it cannot cross. This is its boundary. So that's why they're saying, well, what's the domain then? What is the smallest x value you have? -2, but you cannot touch it, this parenthesis, until infinity. So domain vertical asymptote. The next one. Right 5 and up to. So right 5. So let me draw here. The original one goes to the x value 1. So this is log base 3 of x. You are taking this x-intercept, going 1, 2, 3, 4, 5, and then 1 up, 2 up here. So always indicate your steps. And then you are drawing your graph. So what is the vertical asymptote? Which line you cannot cross?
5.
Only 5? X equals 5. It's a line, so it's a formula. It's an equation. X equals 5. So this is 1, 2, 3, 4, 5. So 5 is here. This is the line you cannot cross. That tells us our domain. What's the domain? Five parentheses in quotes. So the lowest you can get close to is -5, but you cannot touch the 5. You cannot use your 5. So 5 to everything else. Any question? And these are the actual pictures. Three last questions. So this is a reflection about what? X or Y? X. Reflection about x-axis. And then -5 means? Right 5 up to. So The normal graph is here. Oops. Oh, since it's up, let me go a little bit down. So this is one. You are reflecting this one about x-axis. So this is your mirror. So if you reflect, the top portion goes the bottom of the x-axis, and the bottom portion goes above the x-axis. So this is negative log base 2 log base 3 of x. Now this reflection, you're taking 1, 2, 3, 4, 5 right, and 1, 2 up, and you are drawing a reflection here. The graph you have here is the same graph you have here. Asymptote, vertical asymptote, x equals 5. So this is x equals 5. 1, 2, 3, 4, 5. So this is the line you cannot cross. And your domain, infinity. One of these will be in the final exam, either from the exponential or from the log or from both. Any question? The last two. It's ln, but same as log. It's same shape, same everything. I mean, I shouldn't say same everything. Same shape. Right one. So the quiz, in the next quiz, you're going to draw one log and one exponential transformation. So the normal graph without any transformation, ln of x goes to the x value 1. You're taking your x-intercept from 1 to the next number, which is 2. And you're drawing the same graph again. Ln of x minus 1. So what is your vertical asymptote? Positive 1. So you said x minus 1 equals 0. That gives us x equals 1. The asymptote. And your domain. So you start from 1 and then go all the way to everywhere. Just the word ln. ln means natural log. The last one you try. I'm too lazy. It's same as the last page. So try at least this one. And with this will be our last question. In our next class, we're going to talk about properties. And then we're going to solve some logarithmic equation. Or at least write down the properties and think about them. We're going to discuss them in our next class.
I remember
Yeah.
how many I didn't see that. You already learned. What was the class average for the last year?
I forgot. But it wasn't good. One more page. Okay. So we have 2 pages of properties. See, this student is like you guys. Do you have to remember all of these things? Huh? Yeah. Think about the final exam. You have to put everything in the final exam.
I mean, everything, but not this.
I'm not going to ask you these formulas, but you're going to solve this type of questions, like simplify log using these properties. not on the entire exam. Next exam and final exam, they have two parts. First part is non-calculator, and the second, once you're done with first part, you give us the non-calculator part, and then you get the calculator part. Did you guys copy this? Okay. You're going to re-watch our recording. And also try transformation E.
How does change the base work? Like,
So if you observe your calculator, the log you have in the calculator, they don't have any base. But if you do have a base to work with, that is so cool. Let's say you want to find, they're asking, tell us what is log base 3 of 5. You cannot find this in normal calculator. So you go to the calculator, you do log 5, and you divide by log 3. You're going to get the same result. You guys need to know this change of base. Because your calculator, scientific calculator, most scientific calculator, they don't have base change formula. Once you're done with this, we're ready to go for today. So be safe. See you again all Thursday. And don't forget to do your homework. My math lab is very, very important. If you want to pass or if you want to get what grade you are desiring to get. Ooh. Yeah, we're supposed to have school off, but we don't.
Oh, miss, that's why I was late. Oh, it's a veteran day. No, miss, I thought we didn't have class, so I slept more.
And then how do you know we have
I
class?
texted my friend because he was like, oh, I'm at school right now. I said, we have school?
What a good excuse you have.